Okay, so skill practice 44, number 1A. The rate of disappearance of NaCl will be twice the rate of appearance of Cl2. Now this can be seen by the mole ratios in the equation. There's a 2 in front of NaCl when Cl2 is on its own, making the rate of disappearance twice as much. B. This order would be second order because when you take the ln of the concentration of NaCl and graph it, the graph has a pretty much straight line, making it second order when first order would not have that line. C. Calculate the rate constant K. So using the formula shown and plugging in 0.102 for A and 0.2 initial and 995 for time because that's the amount of time it was taken, you can solve K, which is 0.00231. D. What is the average rate of reaction? Now, you find the slope in 995 seconds, y2 minus y1 over x2 minus x1, which is 6.33 times 10 to the negative fifth. Now, E. For this, to find this, you would take the plot 1 over concentration versus time graph, which is this graph here, and find the slope of the tangent line at 700 seconds. Okay, F, write the rate law for this reaction. Rate equals K NaCl squared. Now it has a squared next to it because there are 2 moles of it. G, calculate the rate of disappearance of NaCl at time 1550 seconds. Alright, so you would take the approximate slope at 15 seconds using the plot 1 over concentration versus time graph, which is 3.13 times 10 to the negative fifth. Okay, H. You can find this by taking the ratio from the original equation since the ratio is 3 to 2, making the rate of appearance 2.54 times 10 to the negative fifth. Okay, skill practice 44, number 2A. Alright, so this reaction would be second order, and you can tell this because the initial concentration to the final concentration, the value does not double, which is what the first order does, and since we usually do not use zero order or are told not to do so, it must be second order. Okay, so the rate constant for this reaction using the formula is 0.117. C. Now you can tell that this takes 34 minutes and you can solve this by using the rate constant we solved for in the previous question, 0.117, and just plugging and chugging into the formula to find 34 minutes. Alright, so skill practice number 55, number 1. Alright, so the delta H would be negative 1453.2 and delta S would be negative 161.84, and you use the formula for free energy, which is shown. To find the change in G, you use the formula concentration of products minus reactants, and then plug in that value to solve for H and S. Okay, for this one, to solve for the change in G, plug in negative 1453.2 kilojoules for change in H, and 161.84 kilojoules for delta S, with 298 Kelvin because it's at 25 degrees Celsius for T, and solve for G, making it negative 1404.9 kilojoules. Alright, 3. Delta H is positive and delta S is also positive, and this is true because delta S is negative and it is spontaneous at all temperatures, but since it is not spontaneous, it must be positive. Also, if delta S is positive, it is spontaneous at high temperatures when the delta H is also positive. So that fits that criteria. Okay, 4. Find the delta G by taking the concentration of the products minus the reactants, which equals negative 241.86 kilojoules, making G spontaneous. Now, when delta G is less than 0, it's spontaneous, and when it's greater, it's non-spontaneous. Okay, so solve for delta G the same way, concentration of products minus reactants, making it negative 1058.4, and since that's negative, the reaction will be spontaneous. Okay, same way, find delta G, same way, and it's 1.73.2 kilojoules, making the reaction non-spontaneous because G is then greater than 0 or positive. Alright.